this video, we are going to evaluate the integral of the square root of x cubed plus 3x plus 5 times x squared plus 1 dx. Now, this looks pretty scary at first, but I promise it won't be that bad. We want to use u-substitution, and we have two kind of choices for what we can choose for u. We see that we have x cubed plus 3x plus 5, and then an x squared plus 1. Now, we know that we want to take the derivative of u, so if we choose u to be x cubed plus 3x plus 5, then we'll get a derivative that starts with an x squared term, and we already have an x squared term, so that looks like it might be quite helpful. So let's try that. We'll let u equal x cubed plus 3x plus 5, so the derivative is 3x squared plus 3 plus 0 dx. Now we can see there's 3x squared plus 3, and we can factor out a 3. So this becomes 3 times x squared plus 1 dx. Now if we want to isolate dx to be on one side by itself, then we can just divide by 3 times x squared plus 1, and get dx. Now we can use this substitution to try to simplify our integral. So this becomes the integral of the square root of u times x squared plus 1 times dx, which is du over 3 times x squared plus 1. Now that's great. We have that the x squared plus 1 in the numerator and denominator cancel out. And so I have a 1/3 over here as a constant that I can take out of the integral. So we can simplify this a bit as 1/3 times the integral of the square root of u times du. Now I can rewrite the square root of u as u to the 1/2. And then it's a bit more obvious how I can take the integral of that now because I have my power rules. So this becomes 1/3 times u to the 3/2 divided by 3/2, which will be times 2 over 3 plus c. Now if I multiply by 1/3, I see that this is 2/9 times u to the 3/2 plus c. And lastly, I need to plug in what we have for u. So this becomes 2/9 times x cubed plus 3x plus 5 to the 3/2 plus c. And that is our final answer. If this video was helpful, please like and subscribe so I can make more content. And if there are any problems you'd like to see worked out, feel free to email them to ashmath1729@gmail.com.